anyone who requests it, and we'll make the recording available. So if anybody has any questions, what I would like to ask is, by default, everyone's on mute, but if you have any questions, if you can simply type it into the questions section, and we'll get to the answers at the end. And so with that, I just want to say that Jordan and I have between us many years of experience in implementing very complex automation systems for IT organizations of major corporations. And we put this webinar together to share our experience. This is not really intended to be a plug for any specific vendor. It's really focused on solving the problems and the tools that are available for solving those problems and leveraging the technologies that are out there. We really wanted to take a kind of a vendor independent look at this. So just to cover our agenda for today, we're going to look at automation and what processes can be solved. So these are the life cycle processes of complex computing environments, right from the time they are requested to the time they're retired. And really, it's going to extend to any processes in IT operations or development, app dev, that are repeatable and involve manual effort today. We'll look at what problems can be solved, things like virtual sprawl, things like governance and compliance in an automated way. We'll look at today's software tools. So the software ecosystem is evolving quite a bit, and it's changing very fast. So you have orchestration tools, you have DevOps tools, you have cloud management platforms and OpenStack and virtualization. So we're going to categorize that and make some sense out of it for you and give you a little bit of idea for the landscape currently. And we're going to cover some business cases. What are IT organizations doing about automation? What are some of the forward-thinking organizations doing, and what are the benefits of that? And then we'll look at the value that data center automation brings. So it wouldn't be a webinar without a survey and some analyst input. So just wanted to set the stage here by talking about an EMC survey that happened earlier this year. They found that 74% believe that automation of infrastructure is imperative to the business growth. Now that is the IT operations of major companies that EMC is involved with. So the vast majority of people believe that they have to automate things because their budgets are shrinking, or their budgets are staying flat and their businesses are growing, which means their budgets are shrinking as a percentage of revenue. And they've got to keep up, and they've got to do some drastic things in order to be able to keep up. And they can't afford to spend or allocate all of their operational resources to keeping the lights on. They have to allocate some resources to innovation. In order to do that, you've got to free them up. 64% expressed the need for hybrid cloud for its agility and security. So really, hybrid cloud is emerging as the dominant platform or cloud architecture. And a number of reasons for that, but a lot of it is driven by resources and the widening skills gap. But it's driven by necessity, and public cloud has made its way into these organizations, whether IT likes it or not. And then on the right side, Ronnie Colville, a Gartner analyst who follows cloud and automation. And really, her advice is IT organizations should not do piecemeal automation. They should really look at a comprehensive strategy and not look at a fragmented approach. Really, that is all about maximizing your ROI and making sure that the automation strategy you've chosen is a comprehensive one affecting all facets of operations. So by definition, we're going to talk about IT automation, data center automation, and it really is the definition that we use is the processes that are involved from the initial request of a complex computing environment to the time that it's torn down. And along the way, so you can imagine, you have catalog and request management for self-service. You want people to be able to choose their own configuration, whether it's a development or production instance or application. Routing for approvals, chargeback, so you can charge by department and get the cost under control. Provisioning of not just OS, but now storage and database and networks, and then application on top of that, and provisioning in such a way that they all work together. There's a lot of automation and that can be done to take care of manual processes that are done today. And then the governance and compliance. So governance meaning policy-based governance of complex computing environments, like controlling virtual sprawl. A common problem is it's very easy to provision virtual environments now, and so nobody's watching to make sure they get used, and they tie up resources if they're not. So you need to have governance policies around that. Compliance meaning automation of things like PCI compliance or internal security compliance, and that means making sure that your systems, if somebody lays down a patch, for example, that causes something to be out of compliance, then you can automatically remediate that or automatically bring a human into the loop to analyze it and lay down a patch on top of that. So this is what we're talking about, really, is the entire life cycle of complex computing environments. A couple of points on automating processes. Really, there's unlimited possibilities. And really what we mean is any process in IT operations that is repeatable and currently done manual can be looked at for automation purposes. You need to look at it objectively. So investment versus return, there's risk depending on how complex the processes are, ongoing costs, organizational impact, conflict of interest. What some companies make the mistake of doing and most people are pretty good and objective in their judgment, but if you're asking somebody to evaluate the feasibility of automating a process that they do themselves personally every day, sometimes you may not get the most objective response to that. So it's something to keep in mind when looking at that. But on the right side, dependencies you really need to consider is what's your cloud strategy, right? Is it public, private, hybrid cloud? You really need to look at that before you start looking at automation, because the automation processes, the processes are the same for governance and life cycle of hybrid cloud or public cloud or private cloud. The processes are essentially the same. You still need to manage that computing environment from the time it's needed to the time it's torn down. But the implementation of those processes is different if you're doing Amazon Web Services or Rackspace versus your own OpenStack private cloud or vSphere private cloud. You need to understand where that's going to end up because the implementation of those processes are different. Infrastructure architecture is a huge dependency, because if you're trying to implement an infrastructure on commodity hardware to drop your storage costs, you may look at one version. Piston OpenStack, for example, is one of the OpenStack versions that allows you to run on commodity hardware. The rest don't. So those are that's a really important thing. And if you want, if you have a huge investment in SAN and you want to take advantage of that, you don't want to throw it away, then another distribution of OpenStack may be more appropriate for a private cloud, right? So those are the kind of dependencies that you need to consider when you are looking at automating processes. Tool sets and software, right? So you also have to look at stuff you already may own. So if you've done an ELA with VMware and you've got as much vSphere as you possibly need, then there's no need to rip and replace that. You can stick OpenStack on top of that and integrate with it so you can take advantage of your existing investments. And you don't have to do a rip and replace, which increases your risk. So those are some of the things to consider when you're automating the processes. So what's different now? Well, there's a few things that are different, and the overall point of this slide is that the bar has come down, right? The barrier to entry for automation is lower because the investment is lower, cost is lower, risk is lower, and the technologies that are available today make it more feasible. Now, why is that? So orchestration, DevOps, virtualization, and provisioning, those tools have matured an awful lot. Virtualization is extremely mature, extremely stable, whether it's KVM or vSphere, very, very stable to be able to provision Windows environments, Linux environments. Orchestration is really people use that term very loosely, but orchestration essentially means the automation of overall business processes coupled with integration to systems. And those tools like Cloudify and Juju from Canonical have increased in maturity tremendously, and so they're easy to implement. And they're open source, right, so the cost is low. DevOps tools like Puppet and Chef have increased and are widely adopted, and provisioning tools as well, right? So the maturity of those tools makes it easier to implement and easier to integrate. Open source, of course, has put downward pressure on the enterprise software providers. So companies like IBM and HP and BMC and VMware are now feeling tremendous price pressure because you can simply go, vSphere, for example, you can go and get KVM. It's open source. You can get it from multiple sources, or it's part of OpenStack. And so you're seeing price pressure on those, and so cost has gone down, risk has gone down, and the feasibility has gone up. And so now the companies that were maybe smaller companies like $500 million or so that could not do automation a couple of years ago because they're just too complex, too resource intensive to implement, and too risky, are now able to do that and get the payoff. So Jordan's going to take this slide. Go ahead, Jordan.
This is Jordan Oringer, CTO of Zeppelin. Thanks, Sam. So let's talk about some of the problems that can be solved using automation. And let's start first by looking at incident remediation. So a typical example of this would be restarting a service. And not only restarting it, but going and documenting it into a service desk, maybe ServiceNow, for example, and logging a ticket, closing that ticket. And then this way we have a documented trail, a paper trail of what we've done to resolve this incident. We can also look at rolling out specific applications in an automated fashion. So this may be patch fixes or code updates, or these might be greenfield deployments. Horizontal and vertical scaling, another very popular one. So especially in certain industries like retail, at certain periods of time during the year, based on specific traffic patterns, we'll want to increase maybe our web front end in response to traffic growth. And we want to do that in an automated manner to make sure that we can service our demand and take those orders. Another very popular use case, a problem that can be solved using automation, would be policy-based governance. So as I mentioned, the public cloud. And one of the issues that we're seeing very common is that developers are constantly spinning up instances of different types that can be very costly on some of the public cloud vendors. And by enforcing a policy, we can, using a toolset such as a CMP, we can make sure that these developers are only able to access certain instances sizes and keep the cost under control. Similar to that problem, we also have virtual sprawl, which is essentially the issue where we have virtual instances that are created but never destroyed when they're no longer needed. Also a cost center, and there's a lot that can be done with different automation tool sets to ensure that we tear down these environments automatically using, for example, the CMP again and a time-based lease system. We also have the issue of automated operational policies and ensuring compliance can be done in an automated capacity. Both of these have tended to be very manual and very intensive over the years. And using a combination of tool sets, both CMDBs and orchestration tools, we're able to do these now in an automated fashion. And we're able to leverage one admin that may have only been able to manage a couple hundred specific instances, and they're now able to manage significantly more, upwards of maybe 1,000 or 2,000 using the same physical resource. Next slide. Okay, so let's take a look at some of the different automation categories and how we carve out some of these different tools and organize them. Now, before we look at those, the one thing that I want to stress is some of these categories are still being defined, and they constantly evolve. With that, there is a great deal of overlap. so certain tools in certain areas are merging on a constant basis. But the one that's probably most familiar with to most of you is the virtualization category. So this is where your VMware vSphere, your KVM, your Zen server, and your different hypervisors carve out different virtual operating system environments and carve out the network and storage subdependencies and have for some time. We're now seeing OpenStack come in and consume KVM and other hypervisors as well, evolving into more of a cloud platform. And that kind of takes us and merges into the provisioning category of tool sets, where we see current tool sets that have been around for some time, including Kickstart, but more progressive tool sets, including Open Crowbar and Ironic, that allow us to lay down your operating system, even on bare metal, using technologies like PXE, but evolving into and up the stack into network in their storage environment through our cloud platforms, and ultimately into the application and database area, using tools like OpenStack Trove to manage database instances and provision them. And the latest phenomenon being container technologies that allow us to package our applications in a manner that they can run on different virtualized environments and bare metal environments without having to worry about dependencies. So this kind of takes us into the DevOps and configuration management category, where we see tools that have been around for a while but that are growing. So we see Puppet, we see Chef, we see Ansible, we see Salt, along with other DevOps tool sets that are evolving at a rapid pace and coming out with new ones every day and new releases that allow us to ensure that we have a consistent and repeatable configuration across environments. With the CMDBs and other DevOps tool sets, we're also seeing orchestration coming into its own finally. Tools like Cloudify that Jen mentioned earlier, and VCO, HPOO, which will be familiar to some of you, allow us to move up the stack and look at automating not only configuration of complex computing environments, but also automating business processes throughout different environments. And at the heart of all this is the important tool set and silo, so to speak, that allows us to implement our hybrid computing strategy across different public and private providers. So it ties everything together into one layer of abstraction. Tool sets here include Scalar, Clicker, Red Hat CloudForms, RightScale, Service Mesh, all common tools that you may be familiar with, or other ones that dominate the CMP space. Next slide, please.
Okay, so this slide really shows you a little more detail about the categories. And so we've broken it up into cloud management platforms, orchestration and DevOps, OpenStack, and full stack. And I'll start with cloud management platforms. And these are tools that are purpose-built for managing the entire life cycle of complex computing environments, from the time that they're requested to the time that they're torn down, right? So they have all the processes that we had talked about earlier built into them out of the box. Now, certainly there are configuration and customization options that you can do, and they all have their own strengths and weaknesses, but they all go about it from different angles, right? So some of them may look at it from a DevOps perspective and be really targeting the application development people in their management of cloud environments, and some of them may be targeting IT operations, for example. And there are there are great differences between these tools in terms of their ease of implementation and overall functionality as a result of that. On the orchestration and DevOps side, you have Cloudify, Chef, Puppet, some of the others that Jordan also mentioned, Ansible and SaltStack. The orchestration tools are really generally about generically automating business processes, and so they have scripting capabilities, integration capabilities, and that's like Cloudify. And Juju would be also another example, which we haven't listed there. But Chef and Puppet, for example, are really DevOps tools, and they're focused on the DevOps or the development team that is deploying applications in computing environments, in complex environments repeatably and through automation, but they also have the configuration management component. On the OpenStack side, what we found is that there is not a whole lot of education and understanding across the, I guess, Fortune 1000 companies in the United States about OpenStack itself. And there is a huge difference between distributors. They all do one thing, right? They all distribute their version of OpenStack, and they sell support services associated with that. So a company, it's the same story as how Linux got adopted. Is people didn't want to adopt a pure open source piece of code. They wanted a company behind it, and Red Hat provided that support. So it's the same model as that. And we believe that the adoption rate is going to be increasing significantly, mainly because you can do things at a much lower cost than you can do it with traditional enterprise software. But the differences are tremendous, right? So OpenStack has a number of projects, and I think they're up to 15 or so projects, and each project is a module. And not all the distributors support all of the modules, all of the projects. So for example, Piston is really well engineered to run on commodity hardware. So they have a layer in between OpenStack and the bare metal that they call the Piston OS, which is essentially a cluster operating system. And so that enables you to abstract the hardware. None of the others have that. Red Hat supports a wide variety of the OpenStack projects, and Canonical and Mirantis as well. What you find is in the larger companies, the corporations that are jumping on the bandwagon like IBM and HP and VMware, they are, of course, stressing integrations with their own software tools. They're not, if you take the independents like Mirantis, Canonical, Red Hat, Piston, they are focused on developing functionality for the ecosystem as a whole, what is better for the OpenStack user community. Whereas the big software vendors are more focused on developing optimal integrations with their own software. They're more about pushing their own software, which is okay. You get some great integrations, but it's something to keep in mind if you're choosing an OpenStack provider. So for example, IBM is ensuring that there's very strong integration with DB2, which may not be important for all OpenStack customers that are using MySQL or MongoDB or something along those lines. VMware is making sure that there's tight integration with vSphere, which I think is a good thing. But these are things that you need to consider. And then HP is ensuring that they've got tight integration with their cloud management platform, their CSA and operations orchestration tool set. So then you have the full stack providers, which are companies that provide, they're enterprise software companies that provide the whole suite, and they've positioned it as that. But really the way they've arrived there is completely opposite from the cloud management platform providers. They've arrived there by acquiring multiple companies and piecing them together. So for example, HP has Propel for their catalog that they've developed internally. They have CSA, which is their cloud system automation suite, the provisioning and automation. They have an orchestration tool that they bought with Opsware, and they've bundled these together, and that's their message. So the full stack providers are all in that category. VMware, same thing with VCO, VCOPS, and VCAC, which they've now changed to the vRealize suite. Same sort of idea. But there's a vast difference in functionality and strengths and weaknesses, and of course the cost. If you look at some of the cloud management platforms, Scalar and Red Hat, for example, are open source. And so typically the implementation and total cost of ownership is going to be lower with that.
So we've included a recent copy of a reference architecture just to reinforce the point that we want everyone to look at hybrid cloud strategy and data center automation by looking at the actual components and not the actual software pieces. Essentially take a step back and think about these different pieces that are needed to truly automate the full life cycle of the environment. And then select best of breed tool set that you may already have an existing investment in some of these areas and work on integrating them and fusing them together. So looking quickly at this, we have kind of a quick snapshot of what's running in our hybrid cloud lab environment and some of the tools that we're kicking around for different customers and different use cases on a daily basis. It's by no means encompassing, but just to give you a perspective of the integration and workflows and communication between them. So in the top left, we have catalog management, which Sam mentioned before. So this is taking your self-service user request and moving then to and communicating with a chargeback showback system as required for accounting needs. And that's closely integrated to your catalog chargeback showback with your provisioning tool set. So that's a multifaceted, multi-stack, starting with your operating system and storage layer, working through networking up into your database, and ultimately what depends on your database, which is your front-end applications, right, and application servers. Moving down, we see provisioning closely associated with some of the management tools, orchestration tools, and monitoring that we mentioned prior. CMPs being a very important component of tying together not only provisioning but eventual management of the hybrid computing strategy, which consumes both public and private cloud resources. Once you go through orchestration tools, which include some of those DevOps tools that we mentioned prior, we look towards maintaining policy governance and compliance. And many of the same tools, as we see here, are overlapped and very closely associated to ensure that we maintain not only an automated life cycle, but ensure that the business needs from IT are being met at all times throughout the process. And we feel that the one thing that we want to really stress and reinforce here is the need for a strategy, a hybrid cloud strategy, to be defined before you go in and select these different tool sets. It'll enable best-of-breed software to be implemented and integrated, and it'll also ensure that the investments that you have made and the investments that you'll continue to make are future-proof as much as possible as you move through your IT strategy as it evolves. So past reference architecture, let's talk about what other organizations are already doing today within the automation spectrum. So different organizations are at different stages of the process, but it starts, in our opinion, with basic tasks. So these are scripts, basically taking scripts that you likely already have in different areas of your organization that your administrators and engineers have built, and centralizing those into a repo and improving upon those so that and documenting those so that the business is aware of these scripts that are being used generally on a daily basis. Along with that, you have OS updates, operating system updates, and service restarts and password resets, which are common processes, basic tasks that can be automated using orchestration and CMDB tools on a daily basis. This is where you want to start. Essentially, take the low-hanging fruit, so to speak, and then you can evolve, moving into the next stage, which is essentially a combination of those tasks. So you're going to need to build upon those basic tasks and maybe run a few different tasks in parallel for you to do something like incident remediation resolution. So that was one that we'd mentioned earlier, where you may want to restart a service, right, which is a basic task, but you want to build on that and not only rectify the situation, but for ITIL compliance, log that into a service desk, close that ticket, and maybe even go and page and alert an admin, depending on the severity of that issue, to make sure that it was addressed appropriately. You can also use a combination of these tasks within automation to tackle issues like virtual sprawl, scaling, DevOps, and release management. So that's going to be your continuous integration, continuous delivery. Once you have, you're kind of at this midway point of taking a lot of these basic tasks, bundling them together into a combination of tasks, you ultimately want to progress to automating business processes. And here we get to look at really the essential building block, a component of the total IT lifecycle, right? And this is going to look at things like implementing a catalog. so allowing your developers or different departments to come in and select in a self-service capacity the different resources that they need to consume. Implementing chargeback and cost management systems so that the selection that's made in a self-service capacity can not only get routed for approval, but it's debited from the particular budget that's required, and it can be tracked by the different finance individuals within an organization. We then can move to looking at provisioning complex environments, so in total stack within that. So we looked at the different components, so not only OS and storage, but moving up through the stack into network requirements and ultimately database and application requirements and the different dependencies that are required to cluster those applications across instances, and in some cases even facilities. We get to eventually looking at governance, right? So we want to make sure that policies that are implemented by IT are assistive and predictive, and those things can be implemented with automation through the different tool sets that we discussed today. The last one being patch maintenance and compliance. So this is essential to ensure that, especially with external auditors, that you make sure that you're ensuring that things like PCI and HIPAA compliance are maintained throughout the process. And not only are they maintained, that when you lay down patches that may be out of compliance, they're rectified immediately in an automated capacity, and the correct individuals are notified and the incidents documented to ensure that you're meeting the requirements and preventing additional exposure for your organization to the world. Ultimately, once you get to this kind of third tertiary stage, you can then look at assembling these different business processes into the total IT lifecycle that can be automated. And once you reach this essentially fourth stage that we haven't depicted here, but it ties together these different business processes, is kind of the ultimate goal and vision that we share for the automated hybrid cloud data, lights out data center.
Okay, next we're going to cover a couple of case studies, and these are just brief illustrations of some companies that have implemented certain solutions for automation and have paid big benefits. Right, so one is a global technology manufacturing company. They had no governance over development environments. They were running 24/7 virtual and physical systems on a public cloud, and they're paying by the hour, right? So they had, you can picture they had development teams in various countries in all continents, in Europe and Asia and North America, and they were basically just running the virtual environments constantly 24/7 with no regard for spinning them up or spinning them down based on schedule. And so what they did was they automated the shutdown of the virtual and the physical environments using orchestration, and they incorporated the development team's work schedules, and they stopped the systems when not in use. And so they did that just using orchestration and the integration with the group scheduling system. And the result was they dropped their cost by 60% in billing for public cloud. And then in the private cloud, it was reduction of utility bills, reduction of support staff, because the workloads did not have to be operating all at the same time 24/7. So this is a great example of some low-hanging fruit that they just simply picked a spot where you have waste going on that can be managed with automation. And so tremendous ROI there, and very low cost to implement.
So another use case that we wanted to share with you is for an online tech company, specifically the HR services for the company. And they had two problems. First of all, their performance SLA wasn't being met. So their application wasn't available at achieving 5 nines or greater as they had wanted. And the second issue with that was the cost was higher than desired for the amount of time that was actually being spent interfacing with these systems. So the solution included a few different tool sets. Foremost, they redid their architecture, implementing a multi-VM load balance front end, which allowed instances to be added and removed without users noticing when accessing the application. with that, a cloud management platform, a CMP, monitoring solution, and an orchestration tool were all integrated within their architecture, essentially allowing them to scale up and down based on different parameters. In this case, it was the number of users that were accessing these HR services systems, and ensuring that there was enough instances online to meet the demand. And when that demand scaled down and users were no longer accessing the system, orchestration was used to reduce the amount of instances that were running the application. And the result here was that when users were active and online in the system, they met the 5 nines that they needed for their application. But at the same time, when the application wasn't very busy, instances were shut down and terminated, allowing them to reduce costs by scaling down.
So in just some things to consider when you're embracing an automation strategy. We're just going to recap a little bit of what we've talked about already. So cloud strategy, architecture, and roadmap are key to getting established before you really look at automation and automation strategy. You should step back and look at all the manual processes objectively. ROI, short, medium, long term, expectations, and risks. Identify the software tools. What do you already have? What can you leverage that's open source? What do you need to purchase? A lot of companies have a lot of shelfware, and they're very tired of buying that shelfware from enterprise software vendors. So this is really about first taking an inventory of what you have and leveraging what you have rather than going out and buying a new solution. In many cases, we find that 80% of what's needed to solve some of these problems is already owned by the customer or is open source. Taking baseline measurements is really important because how do you measure success, right? You need to understand where you've been in order to realize if you've been successful or not. So the average number of admins per server is a great measurement of physical and virtual, and it's not uncommon in these automation scenarios to go from 1 admin for 50 servers to 1 admin for 500 servers, and 500 useful servers, not virtual sprawl as well. So server utilization, not just systems deployed, but those that are actually used. The average time to deploy, it's not unusual for companies to go from 4 to 6 weeks to deploy a server to 30 minutes. And the average compliance rate, which is a little bit more difficult to measure, but security and PCI internal standards, those can be measured by comparing with manual audits. But if you automate that, then it becomes a whole lot easier. Cost of insurance of compliance, including the manual effort. So these are just overall some things to consider when you're looking at automation solutions. And then to summarize, I think it's important to stress a few points. Automation is not an option. So I know that a lot of IT organizations today have security on their mind first and foremost, but automation is actually not an option anymore because when you're dealing with a flat budget and your company is growing, you're actually dealing with a shrinking budget because you're shrinking as a percentage of revenue, and you have to increase productivity dramatically to support a growing business without additional money. You're going to be at the point as a CIO or IT manager where you're going to be the person that is inhibiting company growth, and no CIO wants to be in that position. Adopt an overall strategy. Think about it in conjunction with your cloud and infrastructure architecture. Every IT organization is unique. Organizations are different. They've got different nuances, different dynamics, and you really need to look at it as an individual solution to an individual problem in your specific company. And with orchestration, there really is no limit to what can be automated. Because of the integrations are easy, you can integrate it to legacy systems and really automate overall business processes. So at this point, we are going to open it up for questions, and I see that we've already got a few coming in. So I would like to start it off by reading what we've got here. And first question is, what does OpenStack do that vSphere does? Or what can I do with OpenStack that I can do with vSphere today? Jordan, you want to take that one?
Yeah, I can take that one, Sam. So the short answer is pretty much everything, except for some proprietary features and modules that would have been written by VMware or some other third-party ecosystem. But you shouldn't consider that to be a deal breaker, because if you are using one of those third-party tools or something from VMware, like something specific to maybe for their thin desktops, for their VDI, because there are other solutions in the OpenStack community to support the virtual memory streaming function in that example. For example, in Piston OpenStack, they have a feature called blessing instances that uses similar BMS technology to VMware's VDI thin desktop type of solutions. So there are solutions out there, and essentially anything that you can do with vSphere, you should be able to do with OpenStack today. It is ready for prime time.
Thanks, Jordan. The next question is, what is the difference in functionality between OpenStack and a cloud management platform?
Okay, good question, because they tend to be, in our experience, confused. And essentially, let's first look at OpenStack. So OpenStack's a cloud platform that ties together different hypervisors, by default KVM, but also ESX. Storage resources, you've also got network and images, right? And it ties those together to produce and manage instances, which were virtual machines for our VMware users. On the other hand, the CMP, which is a cloud management platform, is a cloud platform agnostic tool. So it can, meaning that it can work with OpenStack, it can work with VMware, it can work with different public and private cloud platforms. And it ties them together in a single pane of glass, a single layer of abstraction that lets you manage them throughout the life cycle, right? So all the way from spinning up to eventually tearing them down.
Great. And final question, can you elaborate on the functionality of a DevOps CMDB tool versus orchestration?
Okay, another good one. So essentially, if we step back, so a CMDB's been around a while, but in essence, it's used to manage configurations, complex configurations, and then ensure that in a repetitive manner, it's laid down on these different your different instances, right? Those could be, that could be a small handful of instances, that could be hundreds of thousands of instances, but it's repeatable. And on the other hand, an orchestration tool is, we look at it as being complementary to a CMDB. They're not substitutes. So an orchestration tool, instead of focusing just on complex, repetitive configurations, an orchestration tool is looking at essentially automating, defining and automating your business processes, repetitive business processes. And in many cases, it depends on the CMDB for configuration state data, and they can work together. And in many instances, for example, with Chef 12, we're now seeing some of the CMDBs expose and create more orchestration level capability using their existing CMDB code base.
Okay, great. And I think that's all the questions that we have. So at this point, we'll be ending the webinar. And I'd like to thank everybody for attending. And please feel free to send any questions, comments to me or Jordan. And I'll be happy to send out the slide deck to anyone who's interested. Thank you very much.